right, guys, so today we are going to be working on something that's a little bit hard. It's a difficult concept, but I want to go back and look at what we did yesterday. Yesterday, a lot of you guys missed problems on your quiz because you didn't think about what Miss Val and I taught you. Number one, I taught you in the lesson, the video that you should have watched, but also we taught you during our class times. So remember, this was one of our prime factorizations for one of the numbers. So even Miss Val's class, you might have had a prime factorization that looked like this. But when we told you you wrote it in your answer, we told you very specifically that you had to go from the least to the greatest numbers, which is why the 2 4s from here are now down here. That's why the 5 is the next number, so now it's down here. Then the 8s are the next biggest, so that's there, and the 9 is here. So really following directions is a big thing here, so be careful. All right, and so today we're going to be working, like I said, with powers and exponents. So you're going to write down chapter 2, which the name of the chapter was Multiply Whole Numbers. I always have pencil issues when I come on with you guys. Multiply whole numbers. See? It's either too long or too short. Multiply whole, oh my goodness, I need a pencil. Whole numbers. And today's lesson is lesson 2. And that one is powers and exponents. Powers and exponents. Not the best writing in the world. While you're finishing up writing that, I'm going to try to grab a pencil that actually decides to work. Okay. So powers and exponents. So first of all, let's look at some vocabulary. So I'm going to, down here, I'm going to skip a little bit of space, and I'm going to write, oh my goodness, it's just not a pencil day for me. I'm going to write a 10. It's a pretty big 10. And I'm going to write a little 3 next to it, okay? And I'm going to tell you that this says 10 cubed. So in word form, this says 10 cubed, okay? So this 10 is what is called my base. It's the number that I'm going to multiply. This 3 is called, this 3, if it's the little number up here is a 3 today, that's an exponent. And that's the number of times I'm going to multiply the base. So exponents to some people are one of the most difficult concepts to understand, because when you see this, you might want to do 10 times 3, but that isn't what this says. It says 10 cubed, which means it's going to be 10 times 10 times 10. So let's look at this. This base is the number here. It's the one that's multiplied. And the 3 is the one that says, hey, let's multiply it by itself 3 times. Okay? So the base is the number that gets multiplied. And that exponent, it tells you how many times, to multiply the base by itself. Meaning, if you look back here, I'm multiplying the base by itself. So 10 times 10 times 10, 3 times. Okay? Now that might feel a little bit weird, but it's the way we roll. Okay? That's how exponents work. Exponents are cool. You're going to be using those a lot in 5th grade, middle school, high school, college. Okay? You will use those. And if you are working in construction, Anything that has to do with construction, engineering, that's when you would use squared or cubes. That's when you would use exponents, okay? And we'll get into that more as we get further into these lessons. So now we have this here. So let's do one more example in our books here. And so we have it when we're ready to take a test. So here's an example. And we'll do 8 times 8 times 8 times 8. So we're actually working backwards from where we were up here. So 8 times 8 times 8 times 8 equals a number. But right now we don't need to worry about what that number is. What we need to do right now is write this in exponents. So I see 8 is the number that's multiplied by itself. So 8 is my base. Then I see that I multiplied 8 1, 2, 3, 4 times. So 4 becomes my exponent. And you see how the 8 is big and the 4 is little, and it's up in that top right corner. Okay, so we're going to, this is actually write the product as an exponent. So this is an example of that. Write a product as an exponent. Well, this is how you would do it. You aren't, right now, you're not really saying that 8 times 8 times 8 times 8 equals, and then giving me a number. You're just telling me it's 8 to the 4th power. Okay. Now, let's go back. So this is one example. Here's another example. And we're going to find, we're actually going to change. So I'm not going to write in my book for a minute. I'm going to take you guys over to your math paper, which is on page 95. So on 95, you can see this is like the one we were just doing. So you're going to write these as each product as an exponent. So I just did this one for you. 8 times 8 times 8 times 8. What's your base? It was 8. And what's your exponent? Well, there's 4 of them. So it's 8 to the 4th power. Okay, let's try number 4 together. What's our base here? What's the number that's being multiplied by itself? Well, that's a 3 is being multiplied by itself. And then we have 1, 2, 3, 4, 5, 6. So it's 3 to the 6th power here. Okay. Let's do one more. We'll do 1. All these ones. So the number 7 over here. What's our base? Well, the base is the number that's getting multiplied together. So it's 1. And then there's 1, 2, 3, 4, 5 of those. So 1 to the 5th power. Okay. Now, going back to where we originally started when you had 10 cubed and you had to break it down into these pieces, let's go ahead and do 10 to the 4th power. Now, I should mention, actually, I'm going to write that down in my notebook, and let's have you guys write it. If it's a number with a little 2, we say it's squared. So in this case, if I did 8 with a little 2, it would be 8 squared. Okay? If I have a 3, then it's 9. In this case, it would be 9 cubed. But every other number is just, let's say it's 9 with a 6. That would be 9 to the 6th power. That's what you say. Or if I have 10 with a little 8, it would be 10 to the 8th power. 8th. Uh-oh. E-I-G-H. 8. Somehow I'm spelling 8th wrong, and I know how to spell 8. E-I-G-H-T. 8th power. Okay? So if it's a 1, don't say anything. Like, let's say it's 7 to the 1th power. You would just say 7. Nobody's ever told you, oh, I'm 7 to the 1th power years old, right? Okay. So when you look back over here, we'll do this one because it was very similar to the one we already did. So 10th to the 4th power, they want you to write each power as a product of the same factor. So that's 10 times 10 times, wait, how many 10s do I need? I need how many? I need my exponent many, which is a 4. So 10 of them. 1, 2, 3, 4. Okay, so that's answering the product of the same factor. But then I need to find the value. So we want to solve this problem now. So I'm going to come over here and I'm going to say 10 times 10. Well, we know that equals 100, correct? Okay, so if that's 100, then I need to multiply that by 10 too. And hopefully you guys know that 100 times 10 would just give you 1,000, correct? And then if I'm multiplying it by one more 10, then now I'm at 10,000. So my answer here is 10,000. So this problem is not right until you have your product of the same factors and you have the value. So on each of these, you have to give us 2 answers. So let's try this one. We'll do 6 together, okay? So 6 to the 5th power leads me to believe that 6 is my base. That means 6 is going to be the number that gets multiplied, and 5 is the number of times we're going to multiply that 6. So I've got 1, 2, 3, 4, 5. Okay? So that's question 1, product of the same factor. Question 2 is how much is this worth? Well, this is going to be hard. This is not going to be easy. So 6 times 6 equals 36. So I took care of this one, and it's okay if you guys cross these out as long as we can still see them. You don't have to, please don't scratch them so we can't see your work. So now that we have 36, we need to go to our next 6. So we're going to do 36 times 6. So I'm going to cross that out so I remember that I used it. So 6 times 6 is 36. 6 times 3 is 18 plus 3 is 21. So now I'm at 216. Now I need to use my next 6. So I got 216 times 6. All right, and we're getting close. So 6 times 6 is 36. 6 times 1 is 6 plus 3 is 9. 6 times 2 is 12. So now we're at 1,296. But we're not done. We have one more 6 to go. So over here, since I have room, I'll do 1,296 times one more 6. And so 6 times 6 is 36. 6 times 9 is 54, plus 3 is 57. 6 times 2 is 12, plus 5 is 17. 6 times 1 is 6, plus 1 is 2. So you should have, what did I write it to? Okay, here we go. 6 times 1 is 6, plus 1 is 7. I don't know what I was thinking. Okay, so it's 7,766 is your answer. Yep. Okay. Now, this is hard. This is probably your hardest one. That's why I helped you guys do it. But you can see that these numbers get big. As we start to multiply more and more numbers together, they start to get really, really big. Okay. Let's see one on the bottom. We'll do one down here. So we'll write the prime factorization of each number using exponents. This one's totally different. So on this one, I'm going to take 56 and find the prime factors of the problem. So I know that 56 can be made from 7 and 8. And like we did yesterday, I know that 7 is a prime number, so I'll circle that. 8, however, is not prime. It can be found with the numbers 2 times 4. Again, 2 is a prime number. So now I go over to this 4. It's not prime, so I'm going to have 2 times 2. Okay, so I circle all of these. All right, now I'm going to write these over here even though they're not my answer yet, just so I can see all of them. So I have 3 2s, 2 times 2 times 2, and I have 1 7. But that, again, it's not my answer yet because I have to use exponents rather than all these numbers. So I see 1, 2, 3 2s. So I'm going to write 2 cubed because there's 3 2s. And I only see 1 7, so I'm just going to write that. I'm not going to write 7 to the 1th power, remember? So this right here is my answer. So it's 2 cubed times 7. Now let's try this and see if you guys believe me. 2 times 2 is 4, times 2 is 8. Wait a minute. 8 times 7 equals 56. So it works, right? Okay. Now, I want you to be very, very careful with this. If you rush through your work, you're going to get all of them wrong. And yes, you need to do the back side of this. Okay, if you have questions, come and ask us. We're here and we want to help you. Okay? Okay, good luck. Ask if you have questions like I just said. You got this. We want to see both sides of your work and your math notes, please. Thank you. Bye.